welcome to The Explainer. So today we're going to dive into two really powerful ideas that are shaping, well, pretty much everything in technology: AI agents and classical parallel computing. Now, they both promise some incredible speed and scale, but, and this is the key, they get there in fundamentally different ways.
So to kind of get our heads around this, let's start with a question. Is one of these new smart assistants really just a souped-up version of what we've had for decades? Just a faster calculator? Or are we actually looking at a completely different kind of machine?
I think the best way to really grasp the difference is with a good analogy. So think of classical parallel computing as this hyper-efficient, perfectly synchronized factory assembly line. And then think of AI agents as a collaborative team of specialized experts, all brought together to tackle a really complex problem. Okay, first up, let's take a closer look at that assembly line. What exactly makes it tick, and why is it so incredibly powerful for certain kinds of problems? You see, parallel computing is really all about one thing: accelerating computation. That's its job. It's designed to take a huge but very well-defined problem, say rendering a single frame in a 3D movie, and just chop it up into thousands of tiny, identical pieces. Then it throws an army of processor cores at it to solve all those little pieces at the exact same time. The goal here is just pure, predictable speed.
And its workflow is just as rigid and predictable as a real assembly line. A programmer has to define every single step in advance. You break down the problem, you write the code to run the pieces in parallel, and then you stitch all the results back together to get your final answer. It's a straight, linear path from A to B. No detours.
Okay, so now let's leave that factory floor and go meet the team of experts, the AI agents. And this is where the entire philosophy of how work gets done just completely changes. So, unlike that assembly line, which was built to speed up a known computation, an AI agent is designed to coordinate decision-making. This is key. You don't give it a super detailed instruction manual. Nope. You give it a high-level goal, something like, hey, plan a new marketing campaign. And it's up to the agent to figure out the steps on its own. And this is a perfect illustration of their process. See, it's not a straight line at all. It's a dynamic loop. An agent gets a goal, it makes an initial plan, and then it takes action. But, and this is the crucial part, it then observes the outcome, learns from what happened, and then revises its plan. It's this continuous cycle of acting, sensing, and adapting. So what we have here is the rigid, efficient assembly line on one side and the adaptive, collaborative expert team on the other. Let's put their core philosophies right next to each other to really see where they split. Now, what's so fascinating here is you can see this fundamental divide. Parallel computing is deterministic. It's rule-bound. Its execution is a straight, pre-programmed path. Agentic systems, though, they're stochastic, based on probability. And they're goal-driven. They operate in that recursive loop we just talked about. And this difference becomes absolutely critical when something unexpected happens. A parallel system, when it hits a snag, is designed to either throw an error and just stop, or maybe retry the exact same task. But an agent? It's designed to recognize the failure, take a step back, and fundamentally rethink its entire strategy to get around the obstacle. I think this quote just captures the whole thing perfectly. One architecture is built for predictable, repeatable perfection. The other is built for resilient adaptation in a messy, unpredictable world. So all of this leads us to the biggest misconception about these two technologies. And honestly, it's probably the most important insight of this entire explainer. So here it is, the crucial point. These two powerful systems are not in competition with each other. One is not here to make the other obsolete. Not at all. In fact, they have a symbiotic relationship. One is built directly on top of the other. Together, they're forming a brand new, way more powerful kind of computational stack. And this shows that relationship perfectly. See at the very bottom, you've got the raw muscle, the parallel compute layer of CPUs and GPUs. This is the engine. And sitting right on top is the AI agent layer, which acts as the cognitive control. That's the driver. The agent decides where to go, and the parallel hardware provides all the horsepower to actually get there. Okay, so why does any of this distinction matter in the real world? Well, because if you understand this architecture, it tells you exactly which problems to solve with which tool. You use the assembly line. Parallel computing, when the task is known, it's repeatable, and speed is absolutely everything. Think of those complex physics simulations or rendering a big-budget movie.
But you call in the expert team, the AI agents, when the goal is a little ambiguous, the path isn't clear, and the system needs to adapt on the fly, like for automating customer support or conducting open-ended research.
So what's the big idea you should walk away with from all of this? Let's bring it all home with one last clarifying thought. This is it. This is really the one-sentence summary of our entire explainer. It's not about speed versus smarts or efficiency versus autonomy. It's about two different kinds of optimization, the engine and the driver, working together to solve problems we never could before. And that leaves us with a pretty provocative question for the future, doesn't it? As the engine of parallel computing gets exponentially faster and the driver of AI agents gets way, way smarter, which one will ultimately define the next wave of progress? Something to think about. Thanks for watching.